In the common drain or source follower circuit, the input is applied to the gate terminal and the output is taken from the source terminal of the transistor. In the AC circuit, the drain terminal is AC grounded, which is common between the input and the output. That's why this configuration is referred to as common drain. It is also called a source follower because the source voltage follows the gate voltage. The source voltage is actually the gate voltage minus a certain difference, and this difference is equal to the VGS voltage. Therefore, the source follower can function as a level shifting circuit. As you can see in the small signal equivalent circuit, the input resistance of the source follower circuit is resistor R1 in parallel with R2, which are the biasing resistors. To find the output resistance, if we look up the source terminal, we'll see resistor R'(O). We don't know the value of this resistor, so we must calculate it later. If we look down, we'll see the parallel combination of resistors RO and RS. It is important to note that the load resistance is not included in the output resistance. The output resistance of the source follower is the parallel combination of R'(O), RO, and RS. To calculate R'(O), we set the input source to 0, add an arbitrary voltage source Vx, and calculate the ratio of Vx to Ix. So the output resistance of the source follower is the parallel combination of 1/Gm, RO, and RS resistors. To calculate the voltage gain, I first write the equation of the output voltage, which is the product of the current GM-VGS multiplied by the parallel combination of source resistors. By applying KVL to the gate source loop, we can express VGS in terms of the input voltage Vi and the output voltage Vo. By substituting this VGS into the first equation, we can determine the ratio of the output voltage over Vi. The voltage gain is the ratio of the output voltage Vo to the input voltage Vin. We have already found Vo to Vi, and by applying the voltage divider rule, we can express the relationship between the voltage Vi and the input voltage Vin. Similar to the common source circuit with source degeneration, we also encounter the body effect. The small signal circuit that includes the body effect is like this circuit. The GMB VBS current source is dependent on the voltage VBS, which is the voltage across the current source. Therefore, we can replace it with the resistance of 1/GMB. This resistance is in parallel with the source resistors. So we can write the voltage gain like this, which also includes the body effect. For calculating the output resistance, when we look up the source terminal, we'll see resistors 1/Gm in parallel with 1/GMB. Therefore, the term 1/GMB is added to the output resistance that we previously calculated.